Okay, so that didn't work. Fantastic. Let's try -1. See if that works. Let's erase all this. Okay, go ahead. You guys are faster than I am. See what happens when you try -1. You still bring the 2 down, just like we did before. 2 times -1 is -2. That'll give me -11. -11 times -1 is +11. Add that to -23, and we get -12. Times -1 is 12. Add those together, I get 66 times -1 is -66. -66 plus 52, is that -14? And then -14 times -1 is +14. Add that together, I get 77 times -1. Oh, yay, we got the 0 we wanted. So since -1 is a factor, I know that this polynomial factors into x plus 1. These are the coefficients 1 degree less than what we had. So I guess I have 2x to the 5th minus 11x to the 4th minus 12x plus cubed plus 66x squared minus 14x plus 77. And at least now we got it down to a 5th degree. We'll try those numbers again. Okay, so now I'm going to use these coefficients, 2, -11, -12, 66, -14, and 77. Notice we'll still have the same things to try because I still have factors of 77 divided by factors of 2. So I'm still looking at this list of things to try, okay? And so I would try maybe a half and -1/2, 7 and -7, etc. Okay? I happen to know that 11 halves work, so I'm just going to get to there, okay, in the interest of time. I bring 2 down. 2 times 11 over 2 is 11. Add those together, I get 0. 0 times 11 halves is 0. Add that together, I get -12. -12 times 11 halves is -66. Add that together, I get 0. 0 times 11 halves is 0. I add that, I get -14 times 11 halves is -77. So now I have my x plus 1 from before. I have my x minus 11 halves, since 11 halves is a factor. The 11 halves factors into that, so that means x minus 11 halves was a factor. And then this is 1 degree less than what I started with. So 2x to the 4th, remember, because this was a 5th degree that we were dividing into, plus 0x cubed minus 12x squared plus 0x is minus 14. Okay, this is quadratic-like. So I'm going to take a 2 out first of all. I'll bring it the whole way out front of the x plus 1 and the x minus 11 halves. And then this way, that becomes x to the 4th minus 6x squared minus 7. As I took a 2 out, that's going to make that much easier to factor for me, right? I'm going to have 2 times x plus 1 times x minus 11 halves times, let's see, I have an x squared and an x squared minus 7. What multiplies to 7? Well, that's just 7 times 1, but I need a -6 in the middle, so the 7 will be negative and that will be positive, okay? Where does this equal 0? Well, at -1, right? That's where that equals 0. At positive 11 halves, yeah, I knew those two because I used them with my synthetic division. Where's x squared minus 7 equals 0? That would equal 0 when x squared equals 7. So it looks like I have plus or minus the square root of 7 as zeros as well. X squared plus 1, that's never going to equal 0. X squared equals -1, that's plus or minus square root of -1, plus or minus I, that's imaginary. I'm not actually going to hit 0 there. Okay? So my x-intercepts were -1, 0. 5.5, right? 11 halves is 5.5, 0. Square root of 7, 0. Let's see, square root of 9's 3, so a little less than 3. And negative square root of 7, 0. Those are my zeros. And again, I would find some spots in between and see what's happening. So let's plot some things. Something less than negative square root of 7. Maybe we'll do -4. Something between there. Maybe I'll do -2. Something here. Oh, a 0 would be nice to have. Ooh, 0 gives me 77. If I put 0 in here, that's a big number. And then something between here and here. Maybe I'll do 4. Okay, so let's find those y coordinates in our calculator. Okay, so in my calculator, I put -4 in for x up here. Ended up getting 8,721. Good grief. So I'm going to go by thousands here. 1,000, 2,000, 3, 4, 5, 6, 7, 8. There's 9,000. So -4 is way up here. Okay, and then I know that's the 0. In between here, I put -2, and I got -225. Well, if that's 1,000, then I'll just be somewhere around here, okay? And then I put 0 in, of course, and got 77. Okay, and then I'll put 4 in. I got -200 something. It's a 6 degrees, so I'm thinking it goes up both ways. All right, that's my graph. Well, when I put it on the actual Desmos, I knew I had to, look what I had to use on my y-axis, -2,000 up to 2,000 is what I have there. Okay? Because I got such big numbers. Remember, 4 gave me like 8,000. I can't even see it here because I just went to 2,000. But it's neat to, because of what I did, okay, and again, I didn't get some of these bumps. You're not going to get everything, but we can actually make a decent sketch. We know what's happening at the ends. It was a 6th degree positive leading coefficient. It had to be going up on the ends. Okay, now that's a monster. I'm not going to have you really do anything that difficult on your own, okay? I wanted you to see that you have the capability of graphing a 6th degree and getting a pretty decent idea of what it looks like. And when you graph this on the graphing calculator, it looks like all you see is like this. You don't even realize how far and how low it goes. But if you are doing just a little bit, that didn't take us that much time to do this. You know, that you can figure out what the graph looks like on the ends, find the x-intercepts, find the y-intercept, and then plot 1 or 2 points in between each. Okay? We also want to look at what's happening at the x-intercept. Okay? The graph of y equals x squared minus 4 is crossing the x-axis. It crosses it. Okay? It crosses at 2 and at -2. X squared minus 4 is x plus 2x minus 2. Remember, difference of squares? Okay, x squared plus 4 is way up here. It never hits the y-axis. Okay, and this is x minus 2, or x minus 2 squared. Okay, so it just touches the x-axis once. It doesn't actually cross over. Okay, So what we find is if our 0 has a 2 or a 4 or an even number as the exponent, if the whole binomial is squared or to the 4th, it's just going to touch the x-axis there. If, however, the binomial is to an odd degree, like 1 or 3, then it's going to cross. Okay? If it has an x-intercept there, that's kind of what you want to look at. What degree is that to? Usually it is just 1 and we're crossing, but sometimes it'll be a 2. Okay, and then that means it just touches. Okay, another way to look at end behavior is with this idea of infinity. The limit as x approaches infinity, that means x is getting huge, like 1,000,000. Well, since I know this is a 3rd degree with a positive leading coefficient, I know it looks something like this. The bigger x gets, the bigger y gets. The answer to this will be infinity. As x is going towards infinity, so's y. What about as x goes to negative infinity? Okay, so x is going this way. X is getting really, really small, like negative 1,000,000. Well, then it looks like y is going towards negative infinity. However, something like this is a 4th degree, negative leading coefficient. I know it looks something like this. So as x is getting big, y is going to negative infinity. And as x is going to negative infinity, y is going to negative infinity. Okay? Your answer to these is either infinity or negative infinity with polynomials. And the key is look at the end behavior, and that'll tell you the limit as x goes to positive infinity. That means what's happening to the right of the graph? Well, the right of the graph is going to negative infinity. The limit as x approaches negative infinity means what's happening at the far left of the graph when x is negative? Well, y was also going to negative infinity there. Both answers are negative infinity to that. Okay? Now let's take that inequality, that graph we just had, and use it to find when I'm greater than 0. The nice thing is, guys, we can use this graph, that same idea we did with quadratics, the same thing we did with a linear equation. I'm looking, first of all, where I'm crossing the x-axis. Okay, I know that's 5.5, remember? This was -1. This was negative square root of 7, and this was square root of 7. It's the same graph I did before. Where is this bigger than 0? Where are my y coordinates above the x-axis? Well, right here, and right here. So I use these x-intercepts. Where is the graph bigger than 0? From the time x is negative infinity until I hit negative square root of 7. It's also above the x-axis between -1 and positive square root of 7. It's also above the x-axis from 5.5 to infinity. Okay? Use the graph just like we did before. If this said greater than or equal to, the only difference is I would have brackets at all the numbers. If it said where's it less than 0, then I'd say from negative square root of 7 to -1. See how I'm under the x-axis? And from square root of 7 to 5.5. I was under the x-axis. Okay, so it depends what you're looking for. I would graph it like that instead of doing the test point and looking at the zeros, which is another option. The other option is to use the test point method, where we put all our zeros on the number line, and I put in things before negative square root of 7, like maybe -3. I find out they're all positive there. I put in maybe -2 and get a negative. I put in maybe a 0 and get positive. I put in something in between here and I get negative. I put in 6 and get positive. And then since it was asking for greater than 0, I just use all